what I'd like to do is to give a brief introduction to PT, particularly for those perhaps less familiar. And then I'd like to concentrate really on introducing some of the key aspects of the Eurachem PT guide, which has recently been revised. So we've been hearing quite a lot about the Eurachem guides earlier. So I'm going to kind of use the PT guide to explain PT in a little bit more depth. And then I'll address perhaps a few issues around the quality of PT provision, perhaps before ending with some concluding remarks. So today we've been talking about 17025, and PT is very much a key requirement for ensuring the validity of test or measurement results, and it's very much a requirement of the standard 17025. As you can see on the screen there, and it's also a requirement in 15189, which I think Kyriakis mentioned in his talk. So really, PT is required by any laboratory seeking accreditation to either of these two standards. So in terms of what is PT, well, PT is defined in the international standard for the provision of PT 17043 as the evaluation of participant performance against pre-established criteria by means of interlaboratory comparisons. So PT is very much a powerful tool in the quality toolbox, and when it's used appropriately can bring many benefits to the laboratories. Although the primary aim of PT in most cases is to provide the infrastructure for a laboratory to monitor and improve the quality of its routine analytical measurements. And I think the key point here is that the PT scheme itself will not make improvements within the laboratory. It's the information that the PT provides through its reports and other means enables the laboratory to actually monitor its performance and thereby find improvements and implement those improvements within the laboratory. So I've already mentioned that PT is a key for ensuring the validity of test or measurement results. I mean, in any laboratory, the measurement system needs to be sort of appropriately set up. If it's to make reliable measurements, the methods need to be validated or verified, the instruments calibrated, the staff trained, and some form of internal quality controls need to be implemented. And this is very much what I would call the input measures within the laboratory, and indeed very much we link to those input quality assurance tools as required by 17025 in clause 7.7.1. But what's really important is the output from the measurement system, the measurement or the test result. And PT is the key really for ensuring, it's the key quality measure which is specifically concerned with a laboratory's output. And by doing that, it also provides an independent and external comparison of the laboratory's measurement result, as I've already mentioned, is a requirement of clause 7.7.2 in ISO 17025. And thereby using the results from a PT scheme, it's of particular value to a laboratory because it can identify other problems with other aspects of its quality assurance system, such as the methods, calibration of the equipment, staff training, and so on. So it's very much a key component in the quality assurance system for any laboratory and for achieving and maintaining laboratory accreditation. I'm not going to go through the measurement cycle because Vicky, in her opening talk, very much described the measurement cycle, very much what Eurachem tends to address. But I just want to perhaps relate it a little bit to PT to talk about that PT plays an important part in various aspects of the measurement cycle. So you have those pre-measurement aspects where the issue is being defined and maybe decisions made on the measurement. And PT can play an important part in that. So for an example, you could have a PT scheme, say for toy testing, and the item could be such maybe a doll with eyelashes, and then the laboratory would need to decide how easy it is for that child to pull those eyelashes out, which would create a choking hazard, So therefore, that PT is to see whether the laboratory realizes the type of tests that need to be carried out. And also it can play an important part in the sampling. So it might be, say, for taking samples, say sampling soil from a potentially contaminated field. So I say that's the pre-measurement phase, although I would say that sampling can straddle across that phase and the next phase, depending on whether the sampling is undertaken by the laboratory or independently done. I think PT is probably more traditionally known within the measurement phase. And then the final phase, which is at the post-measurement phase, where obviously some decisions need to be taken. The purpose of the measurement, never for the fun of it, but obviously to actually take some decisions. And again, a PT can actually play a valuable role in that phase of the measurement cycle as well. So a PT could actually issue a case study. And so based on the measurement results of the test items that have been sent out, the laboratory then might need to take some interpretation of the results against the case study. So really the PT plays an important role for each of the three phases, or indeed can be just to be a part of one of the phases, perhaps sampling in the pre-measurement phase, or the PT could be designed to assess the whole measurement process, one or more phases in the measurement cycle, or just part of one of those measurement phases. So again, PT is playing a key role right across the measurement cycle. So now just let me turn my attention to the valuable, I'd call very valuable guidance to any laboratory that's needing to participate in PT, and that's the Eurachem Guide on the Selection, Use and Interpretation of PT Schemes. It's been recently revised. The new edition was published, third edition last year. It's really available to download from the Eurachem website. And as we can see from the slide, it provides a right range of information, provides a useful introduction, and then goes on to address the key aspects of selecting the appropriate PT scheme in which to participate, how to use the PT to achieve maximum benefits, how PT performance is assessed by the PT provider, and then how a laboratory should interpret their PT results. And there's a number of useful annexes which are provided that provides further support and information to the laboratory. So I don't have time in this talk to go through the various aspects of PT and what's covered in this guide. So I'm going to concentrate on two areas which I think is very important, which is the selection of an appropriate PT scheme and the use of PT. In other words, some of the benefits from PT. The two areas which I've put stars against on the slide there. I won't spend time on this slide, but you can see here that the guide aims to really cover the aims and benefits of PT, how to select the most appropriate scheme, then understanding the basic statistics and performance scoring, and then using and interpreting the PT results in order to improve that overall performance of the laboratory. And obviously the guide is aimed at anybody undertaking measurements or testing from sample or sampling, calibrations, examinations, and so on. The guide works on a number of key principles, which are very important principles, I think, for anybody participating in PT and for PT to be of a maximum benefit. So the PT scheme selected needs to resemble as closely as possible the laboratory's routine work. And indeed, the laboratories should treat those PT items as routine samples, so no special treatment given to them. The PT provider needs to provide appropriate and clear information to the participants, both to enable them to make that selection and also to participate appropriately within the PT scheme. And poor performance must always be thoroughly investigated by the laboratory if they're going to fully understand the reasons why they may have not performed as they would have hoped, and indeed what corrective actions might be needed. It's very important when interpreting the PT results that risk is taken into account. And really the one round in the PT scheme only really gives a sort of an indication of performance at that moment in time. So it's very important for laboratories to participate regularly in PT and then be able to trend their results. The PT providers should be open to discuss amongst the interested parties to actually help the laboratories, and laboratories should review the PT participation as an education tool. Really use that that PT participation to really help them. There are many various types of different PTs available. I don't have time this morning to go into them. There's different ways you could categorize them as the guide sort of lays out. So I perhaps recommend you read the guide to understand a little bit about these different types of PT schemes which are available. So let me perhaps now turn to the selection of an appropriate PT scheme, because this really is a critical step. And in order to do so, every laboratory needs to establish an adequate PT participation strategy, which really effectively will address two key questions. How much, in other words, what PTs are required, and how often, in other words, the frequency of participation in each of the PTs. Now, every laboratory is different, so due to many factors, and therefore every laboratory needs to establish its own PT participation strategy. So there's a need to decide on the specific number of proficiency tests in which to participate. This is known in the guide as the level of participation. And once you know the level of participation, you need to decide how often you need to participate. And this is the frequency of participation. And then there are 4 other additional questions which are also useful to consider. Do the schemes required exist for the tests we are carrying out in the laboratory? Are the schemes relevant to the type of testing in the laboratory that we are carrying out? For example, is the matrix a suitable match? Are the PT schemes being provided by a competent PT provider, and are they truly independent? So in developing a PT participation strategy, the first thing the laboratory needs to do is to consider the different areas of technical competence that are in operation. So to do this, there are really 3 key components to consider. What measurement procedures or techniques are being used? What are the properties or characteristics being measured? And what are the products being tested? And then each area of technical competence may encompass several of each of these components. And in order to group the products, characteristics, or measurement procedures within an area of technical competence, the key is the laboratory needs to be able to demonstrate equivalence, for instance, across different matrices. So let me perhaps give you an example. Is the method of detection of salmonella equivalent in a meat matrix as it would be in a chocolate matrix, for instance? And then once the areas of technical competence are decided and the laboratory has defined its level of participation, the next stage is to decide on the frequency at which the laboratory should participate. So there's a number of factors that need to be considered here. And what is key really is the level of risk. And this is very much in line with the risk-based approach in 17025. So risk factors would include the number of measurements that's being undertaken in the laboratory, how many tests per month, per week, or even per day. What's the turnover or experience of the technical staff? What other sources of metrological traceability are there? Are there known key stability or instability of the measurement procedures? And what's the significance and the final use of the data? Now, of course, PT is only one of the quality tools. So really, in deciding the level and the frequency of PT, it is important to consider other QA measures that might impact on the required level and frequency. This might include what's the regular use of reference materials or certified reference materials within the laboratory. Does the laboratory have any other comparison of analysis by independent measurement procedures? Are they participating in method development, validation, or RM characterization studies? What's the use of internal quality control within the laboratory? And do they participate in other inter-laboratory or intra-laboratory comparisons? So these are all also important to take into account. So having decided on its PT participation strategy, the laboratory needs to select the most appropriate PT schemes in which to participate. Now, it's worth noting that very often the perfect PT scheme will not be found. So it's often just a case of finding the one that is the best fit for purpose. And in doing that, there's a number of different factors that need to be considered. And these are really well documented in Annex A of the PT guide. So I'm not going to go into detail of these during this presentation, but it is important to consider the PT item being offered by the PT provider. Is it suitable? Perhaps considering the routine samples being tested by the laboratory, for the matrix, for the characteristics, say to the concentration levels, to the reporting units. Knowing a little bit about the other participants in the PT scheme is also important. Is it a national or international scheme? And this could impact on the language used, the size of the peer groups, the measurement procedures being used, and the type of participants. Understanding the frequency and dates for distribution of the PT items should be considered by a laboratory when selecting the most appropriate scheme. Does it meet their needs? Does the PT provider allow flexible participation? And when selecting the most appropriate scheme in which to participate, an important criteria perhaps is the measurement results to be reported. Maybe things such as whether the analysis time being allowed by the PT provider is adequate for the laboratory. How are the results to be reported? Is there a choice of measurement procedure? Can measurement uncertainties be reported? And how will the results be assessed? Are all important points. The PT report, that's really the thing that the laboratory's got to give it a wealth of information in terms of interpreting the results. So it's very important that the PT report is appropriate, very important that it's timely. Having spent the money participating in the PT, then the laboratories need to get that report very quickly. And then finally, the PT provider needs to be taken into account. Is the scope of the PT schemes appropriate for the laboratory needs? Does the PT provider offer feedback and assistance to their participants? And are additional PT items for further investigations provided? And participation in a PT scheme is an important element, as I've already mentioned on a couple of occasions, in the quality assurance system of any laboratory. So it really follows that the PT schemes themselves must be of an appropriate quality, which will give the laboratories a high degree of confidence in the PT scheme, and hence the actions they may need to take as a result of participation. An accredited laboratory will need to demonstrate to their accreditation body that they are participating in a PT scheme that is operated by a competent PT provider, and a competent PT provider should be operating to the international standard for PT provision, ISO 17043. And obviously, by participating in a PT scheme that's been accredited against this standard, that will give the confidence to the laboratory that the PT being provided has been independently assessed against this international standard. Now, the use of PT by a laboratory is an extremely important part of implementing a reliable quality assurance system. Now, whilst the basic use is to assess the performance of a laboratory to undertake a specific measurement or calibration, providing confirmation that the laboratory's performance is satisfactory, or to indicate where potential problems may need addressing, there are many additional benefits to a laboratory from participating in a PT scheme, really covering the ability to monitor the performance of the laboratory, the laboratory as a whole, individual members of staff. So you can use PT to assess the performance of individual analysts, or it could be used to assess specific performance of specific methods. And importantly, being able to demonstrate the validity of their measurement results. So there's a significant volume of information generated by a PT scheme, and this can be used to help laboratories to improve their quality and make informed choices about the methods of analysis, the equipment, and so on. Now, I've captured sort of in each of these boxes here the wide range of benefits that a participation in a PT scheme can bring to participants, and the guide goes into more information. And obviously, I strongly recommend that you have a look at the guide to learn a little bit more about each of these different benefits. But PT, can help the laboratory address a number of the requirements of 17025, such as staff competency, method verification, measurement uncertainty, risk management, and performance review. So I've already mentioned that it's essential that a PT schemes provided are of a high quality in order to support the quality assurance system of any laboratory and underpin the accreditation of that laboratory. So, laboratories need to rely on the PT provider, and that standard for the PT provider to use is 17043. And certainly accreditation to that standard reassures the laboratory of a number that they're working to the necessary requirements of the standard. I'm not going to go into the detail, but it's in fact quite similar to 17025. That 17043 covers a range of technical and management requirements. And just to mention that currently the standard is being revised. I expect the new standard will be published early to mid 2023, and the revised standard will very much take a risk-based approach similar to 17025. So in conclusion, PT is a powerful and essential quality assurance tool for laboratories. It reflects the laboratory's actual quality and can address all phases of the measurement cycle. Enables the laboratory to monitor and improve the quality of measurements, a key requirement of 17025. Participation in PT schemes is an essential requirement, but very much the laboratory needs to establish a participation strategy and select the most appropriate schemes to bring them any benefits. The recently revised Eurachem PT guide provides valuable advice to laboratories, and the international standard 17043 is currently under revision, provides the framework for assessing the competency of the provision of PT. Thank you for your attention.